Hi, Riebli. It's time for our song. Good morning, dear Earth. Good morning, dear sun. Good morning, dear trees and the flowers, everyone. Good morning, dear bees and the birds in the trees. Good morning to you and good morning to me. Good morning. Now it's time for our message of the day. Will you read it with me? Welcome to the 6th week of online STEM. Last week we studied temperature. Today we will read about states of matter and experiment with insulating from Mrs. Hopkins. Have you heard of states of matter? I think you'll recognize it when we start to read. And you might even have an insulator mug in your house, so you might have an idea what insulating means. Our story. States of matter. States of matter. Matter is all around us. Everything you can see or touch is made of matter. Even people are made of matter. This girl looks like she's playing with some blocks. They're made of matter. Her book is made of matter. Even she's made of matter. Some matter is invisible. We cannot see air, but air is matter too. What matter can you see now? I see a girl and a boy and a pinwheel, and they're blowing air, but I can't see that. There are 3 states of matter. They are solid, liquid, and gas. Solids have a certain shape. Books and pencils are solids. They cannot change shape. Liquids change shape. Milk and juice are liquids. They change shape when they are poured into something. They fit the shape of a glass or a bowl or whatever they get poured into. Gases fill up space. Helium is a gas. It fills up a balloon. What else can you fill up with gas? Can you take a deep breath? I can fill up my lungs with gas, air. Sometimes matter changes states. A solid might become a liquid. A liquid might become a gas. It looks like this child's ice cream cone that was a little more solid before is now a liquid dripping down their hands. She better eat fast. Ice is a solid, but ice can melt. It turns into water. Water is a liquid. Water can get very hot. It turns into steam. Steam is a gas. Some scientists study matter. They ask questions. They look for answers. What would you like to study next? That is the story. Well, not the story. This is a non-fiction book about solids, liquids, and gases. We're going to do some work learning about solids, liquids, and gases today. So in our book, we learned about different materials, that everything is made out of materials. For example, a book is a material, and glass is a material, and milk and a person's body, and even air is a material. We also heard that there are 3 states of matter. There is solid, liquid, and gas. Like with water that we drink is a liquid, right? And if we let that water get really, really cold in the freezer, like last week, then it becomes a solid water. And that solid water is called what? Ice. You're right. Solid water is called ice. Liquid water, we just call it water. And when the water gets so hot that it becomes a gas, it has another name. It's called water vapor, or it's called steam. You've sometimes seen it coming off of a hot mug of coffee or tea or hot cocoa. You can see the steam rising, and you know that there's some water vapor there that's in the air. But what if we didn't want something to change the state it was in? Maybe if we had, say, hot coffee and we wanted it to stay hot, then we would put it in one of those special mugs called an insulator mug. Maybe we have some hot soup and we put it in an insulator mug so that we could take it to school when we took our lunches to school, and it would stay warm in there. It wouldn't cool down because of that insulator. Well, today we are going to try insulating something and try out different materials to see which one works best, because not all materials work the same as insulators. Some are really great at insulating and keeping the temperature the same. That's what an insulator does. And some are not very good at insulating, and the temperature changes pretty fast, just like if they weren't even there. So we're going to try out some different materials with an ice cube. We're going to get an ice cube and see if we can insulate it so it doesn't melt as fast. And then we'll have another ice cube that has no insulation at all and see how fast it melts. Maybe we can keep our ice cube cold longer if we use a good insulator. Okay, here's some materials you'll need. Supplies, ice cubes, and you want them to be kind of close to the same size so they would melt about the same. Clear containers, 2 or more. I'll show you a picture of mine. I just used lunchbox containers. A material to insulate and wrap your ice cube that you want to test out. Maybe you'll wrap your ice cube in foil, or maybe you'll have a cloth like a t-shirt, maybe bubble wrap, maybe wax paper, or plastic wrap. What else could we try out? Here's some of the materials I found at my house. I have these clear containers that have a red lid that used to have sandwich meat in them. I found Glad wrap, cling wrap that I could probably try. I found some bubble wrap and some foil. What will you use? Here are my 2 ice cubes in my trays. I'm going to take one and wrap it in the foil. Let's see. Here's my 2 ice cubes again. This time I'm going to compare a regular ice cube and saran wrap or plastic cling wrap. So I'm going to roll the cling wrap all around it and compare those 2. That one's not staying very well. Maybe I should tape it. There's that. Here's my last pair. This one I'm going to take one and put it in bubble wrap. Maybe I better tape that too. Okay. So now we wait. I left my ice and the insulated ice, the one that was wrapped in different things, all on my kitchen table. It took at least an hour. I kept checking in on them every 10 minutes or so to see how they were melting. Here's a picture. I also tried doing a video, one of those ones that you speed up really fast to see if I could watch it melt. I'll put that one at the very end of this video in case you want to see. Pick some materials, maybe foil, maybe saran wrap like me, maybe you found some other things. And make sure you have at least one ice cube that has no insulator so you can see how a regular ice cube would melt if it had no insulator helping it keep cold. And then when you see that most of the ice cube has melted from the one that's just sitting in the tray and has no insulator, that's your time to start. Then you open up the other ones and see, is there any ice cube left inside? Okay, this one is kind of melted. It's got quite a bit of water. Here's the foil that started at the same time. Let me open it. And now this one is the cellophane, the plastic wrap. And there's still a little bit of cube left here too. Let me take this off and see. If there's a big ice cube left inside while the regular one just melted in the tray, then obviously you found a good insulator. If only a little bit of ice cube is still there, but it's bigger than the one in the tray, then you have a sort of good insulator. But what if maybe there might be something that doesn't insulate, that actually helps things melt faster? Maybe you'll find a material like that too. So what do you think happened? What was my best insulator? The one that had the biggest ice cube when I opened it up. Which one was the least insulating? The one that actually I did get one where the ice cube was completely melted, and the one that had been in the air, just the one sitting in the tray, hadn't finished melting yet. So the insulator had like uninsulated. It had helped it melt. I wonder which one that was. I don't want you to see my results until you've had a chance to try your own. But I think you might be curious to see which ones were mine. Can you make a guess which material was the best insulator that I tried? Once you've had a chance to finish your experiment, go ahead and continue the video after this and you can see my results. Here's the foil that started at the same time. Let me open it. What? There's nothing inside the foil at all. It's completely melted, but this one's not. So for some reason, my foil didn't insulate anything. In fact, it helped the ice cube melt faster. Isn't that so weird? I guess I won't put my hot coffee or tea inside a foil cup. Now this one is the cellophane, the plastic wrap. And there's still a little bit of cube left here too. Let me take this off and see. Is there anything in there? Ooh, there is. There's something in there. Is it bigger? Ooh, I think that one is bigger than this one. So this must have slowed it down. It's not melted as much as the regular one. So this was a better insulator, wasn't it? Last one. Here is my ice cube on this side that had no insulation. Here's this one that was in bubble wrap. There's some water in there, but oh wow, That's the biggest ice cube I got. So that one melted the least. So this one insulated the best. It kept it cold the best. Can you see that? I think you can. Okay. So, what did you find out? What were your results? Did you find something that was a good insulator and you had a big ice cube left over when you opened it up? Did you find something that wasn't a very good insulator, like my foil, that you would never put your hot cocoa in because it sure didn't help? So, tell me what you found out. You can share it with me at email at rblstem@mwusd.org. And I'll put that email at the end of this video and in the links below. And what else? Oh yeah, I told you I tried to make a sped up video of the hour that my ice cubes were melting. The video is, I think, like a minute long or so, and you can watch it at the end of this and see if you notice the ice cubes melting at a sped up pace. All right, have a great week, you guys. Have fun. Bye.